everybody to this UN World Data Forum webinar on adding value to statistical data production through machine learning. And a particular welcome to those who I can see from the chat are joining us from time zones where it's either very early in the morning or very late in the evening. So it's great that so many people all around the world can join us. So I'm Stephen Vale. I'm a senior statistician and the regional advisor in statistics at the United Nations Economic Commission for Europe, based in Geneva, Switzerland. And I'm responsible for our work on capacity development in statistics. I'll be your moderator for this webinar. And this is the 14th webinar in a series hosted by the United Nations Statistical Division, my colleagues in New York. And it's part of the run-up to the UN World Data Forum. So I guess part of the road to Bern, as it's been called, even if Bern now will also be a virtual event. So the forum aims to foster cooperation and open dialogue amongst governments, academia, international organizations, private sector, civil society, and basically all the other stakeholders that have an interest in data that can be used to accelerate progress towards the SDGs. So the topic for this webinar is about the use of machine learning for statistical production, and we have two excellent presentations coming up. But before we get into that, I'll just give a few rules for the webinar, so that basically the housekeeping notes. First, we already reached 200 participants, so it's very important that everybody keeps their microphone muted unless you're a designated speaker. We certainly can't cope with having 200 microphones all contributing to sound and giving echoes and so on. So please keep your microphone muted. We'll have time for questions after the speakers have given their presentations. And we're doing the questions in two rounds. First round will be some questions that we've gathered together from what you submitted when you registered for this webinar. So we'll take a limited number of questions that have been pulled together from those that were submitted. And then in the second round of questions, we will be taking questions live from the chat box. So if you have a question at any time during the presentations or during the discussion, please type it in the chat box so that everybody can see. Our colleagues in New York will also be pulling together, synthesizing those questions. So we will ask as many as we can in the time available. But also, I encourage you that if you see an interesting question in the chat, you can also have your response there as well, so we can get discussions going also in the chat box. So, next point, I see that many of you are already writing your name, your country, your organization in the chat box. I'd like to encourage anybody that hasn't to do that. First of all, that will help you find the chat box and how it works. And that's the symbol for a speech bubble that appears at the bottom of the main screen when you click on that screen. So I'll give you a few minutes to do that. And while you're doing it, a short commercial break, because I'd like to just promote another upcoming activity. And can I ask again, please, everybody to mute their microphones, because there's one or more microphones not muted at the moment, giving us some background noise. So I mentioned that there is another event coming up, and this is something in partnership between the United Nations Statistical Division, UNCTAD, the United Nations Conference on Trade and Development, the UN Global Pulse, and an organization called Marine Traffic. And these organizations are jointly organizing a virtual hackathon. This hackathon will take place on 3rd to the 6th of September this year, and that will be right after the conference on big data for official statistics, which will also be a virtual conference this year. During the hackathon, participants will have access to data from something called Automatic Identification System, AIS. And this is data about the movement of shipping around the world. So you can track ships in real time and see where they're coming from, where they're going to. And the idea of the hackathon is to use these AIS data to try to get some insights into topics like climate change or the COVID-19 pandemic. And for more details, my colleagues in New York will very shortly post the URL. There it is. It's just appeared in the chat. So if you want more details about this hackathon, then please have a look at that. So in the meantime, I see many people have added their names, their organizations, etc. in the chat, which is great. So let's get started on this topic of machine learning. And I guess the first question is, what is machine learning? And here I'm going to borrow a definition from my colleague In-Kyung Choi, who I think is already on the call. And In-Kyung used this in a presentation to UN staff about a week ago. And this definition is that machine learning is a field of computer science that uses statistical techniques to give computer systems the ability to learn with data without being explicitly programmed. So really, I guess it means that machine learning is sort of the intersection of statistics, IT, and data science. And it can also be seen as a new branch of statistical methodology that has a great potential to add value to statistical data production, partly by increasing efficiency in statistical business processes, but also by facilitating the use of new data sources, such as particularly big data. So already we're seeing examples around the world of how machine learning techniques can be used for data editing and imputation, how they can be used particularly for classifying and coding data from text responses, and potentially also in other areas, reweighting, predictions, etc. And you'll hear practical examples from the presenters very soon. So we have two outstanding presentations coming up. The first from Jenny Pockney, Principal Data Scientist in the Methodology Transformation Branch in Australia, the Australian Bureau of Statistics. And the second from Alejandro Ruiz, researcher at INECI in Mexico. And between them, they bring a lot of experience and different perspectives to this topic. And I know that they're also very actively involved in the UNECE machine learning project that is about 3/4 of the way through now, due to finish by the end of this year, that has been very actively sharing ideas and experiences between around 15 organizations, and I think over 100 people are involved in some way or another. So it's great that they can join us today, and I think now it's time to hear what they have to say. But I think already, again, we see the number of participants up to 280 now, and many names, organizations, etc. appearing in the chat box, so that's great. So let's go to the first presentation from Jenny. So Jenny Pockney is the Principal Data Scientist in the Methodology Transformation Branch at the Australian Bureau of Statistics. And most recently, she has been leading Big Data Editing Methodology Futures program and contributing to machine learning initiatives, including recommendations for internal machine learning strategic directions and participation in the UNECE high-level group for the modernization of official statistics machine learning project. So over to you, Jenny.
Stephen, can you hear me okay?
Yeah, that's great, Jenny.
Excellent. So good morning and good afternoon to everyone. My name is Jenny Pockney. I'm one of the principal data scientists from the Methodology Division in the Australian Bureau of Statistics. And thank you very much for the opportunity to talk today about some of the work we've been doing and the challenges and opportunities of using machine learning for official statistics. So next slide, please. So National Statistical Organisations, or NSOs, have been innovating for a long time. And over recent years, we've been building their capacity in skills in machine learning. The ABS has been working with others to progress these capabilities, with other agencies, with academics and experts, and with other NSOs. And as Stephen mentioned, we've been involved with the Machine Learning Project under the UN High-Level Group for Modernising Official Statistics. And that group started over a year ago and has been looking into the potential applications of machine learning to improve efficiency and use emerging data, including in the space of coding and classification, editing and imputation, imagery data, as well as aspects of quality and the machine learning challenges for the business of an NSO. And outputs from this group are expected to be made publicly available in a few months. So the field of machine learning is maturing, and it's an exciting time with many machine learning methods, algorithms, and related technologies under development. However, because this field is still maturing, work remains to be done, including understanding how best to harness for the purposes of an NSO. So NSOs need to meet community expectations that they are innovating but using emerging methods in an appropriate way. For example, the publication of trusted national statistics requires robust and repeatable production systems. This means that any innovation such as machine learning needs to be incorporated as part of an end-to-end production system. NSOs also need to ensure their statistical products are robust, transparent, and explainable, and they need to provide metrics that describe the uncertainty and quality. This is a developing area, and the work being done by NSOs can help progress machine learning developments in this space. The international sharing and collaboration through HLGMOS is helpful as a driver and for making these directions clearer. So we know that research and experimentation is important to progress these developments, and it helps build capability and experience and to investigate potential opportunities for using machine learning. So these opportunities include problems that traditional methods struggle with, or where machine learning can provide efficiency or quality gains. For example, using machine learning to help classify satellite imagery data and auto-coding free text survey responses. Next slide, please. So an example of a machine learning project in the ABS is the Address Register Automated Image Recognition Project. Underpinning our census and our household collections is the ABS Address Register, which contains over 10 million residential addresses. Addresses are classified in terms of residential, commercial, under construction, or vacant. And regular maintenance identifies about 500,000 changes per quarter, many of which can be automatically classified using admin data. And the remainder are confirmed using manual desktop review. Ideally, all of these potential changes would be quality assured, but due to resource limitations, only around 34,000 addresses each quarter were able to be confirmed by manual desktop review using aerial imagery and other tools. In collaboration with government agencies CSIRO and Data61, the ABS has developed the AIR machine learning method. This new approach allows the ABS to quality assure at least 7 times the number of addresses using the same resources, saving time and money, as well as resulting in a much better register. Next slide, please. Another project is the Intelligent Coder. ABS statistics are published using standard classifications, which allows for more consistent and comparable data sets. As for the image classification, text autocoders can help reduce the amount of manual effort to code this data into a classification. The Intelligent Coder was developed to improve on existing text autocoding methods used in the ABS. A traditional index-based autocoder uses a predefined index of words, but can still need manual effort to check and code remaining items. The intelligent coder instead uses a machine learning approach, and our testing so far has shown that this can provide higher autocoding rates, improved consistency, and a reduced need for manual intervention, resulting in greater efficiency and quality. So dwelling occupancy. So when collecting information from households, a small number of households that are thought to be occupied do not respond. The ABS imputes persons for these households and is investigating whether a machine learning solution that uses admin data sources can improve this imputation. So land cover and land use is another example. There is a large international community investigating the use of Earth observations data, such as satellite imagery. And NSOs, such as the ABS and the EAGI, have been actively involved in this community. The ABS has previously undertaken research into the use of machine learning to classify satellite imagery data to estimate crop type and land use in order to supplement agriculture statistics. There are a number of ongoing challenges in this space, including the availability of good training data and computing infrastructure. The ABS is working in partnership with other Australian agencies and experts, such as Geoscience Australia, to address these challenges in order to provide useful information products for the community. And as mentioned, the ABS has been undertaking research to investigate potential opportunities for using machine learning and to ensure it is suitable for the needs of an NSO. Next slide, please. Machine learning methods can perform really well. However, there are some other challenges, including the black box nature of machine learning. It can be hard to explain how the method came to a particular solution. And while there are emerging methods and approaches increasingly available, these need experience and subject matter knowledge to interpret. Another concern is about overfitting, making it too perfect, and that it performs very well on the dataset used for developing the model, but potentially at the cost of poor performance during production. Performance needs to be robust to actual use in practice and should be robust over time. To improve the robustness of machine learning methods, randomized resampling approaches have been incorporated. For example, random forest and gradient boosting are ensembles of weak learners and can improve accuracy and overfitting of a single decision tree. However, ensembles are harder to interpret and more computationally expensive, and they do not prevent key variables from being discarded. These issues can impact the robustness of the model over time and over datasets. Also, some judgment is required. Which variables to use, which features to select, improving the training data, and determining the appropriate hyperparameters. So we've mentioned that transparency and explainability are important, which means being able to explain how the process came to a particular decision, being clear about how the assumptions are being made, and providing guidance on the good use of the product. More work also needs to be done around diagnostics and the notion of uncertainty. The ABS is exploring some of the emerging tools that can provide diagnostics and help interpret the models. ABS is also doing research to look into the robustness and quality metrics. For example, whether the replication methods used for traditional estimation can also help us understand how stable a prediction is using a neural network. And can this be done in a way that is unbiased, robust, and yet still computationally efficient? So the HLG machine learning group is also working in this space. And part of that work is developing a framework to assure and evaluate the quality of machine learning solutions for official statistics. It is also important to consider situations where machine learning can help us understand complex problems faster, even if not better. Perhaps machine learning can help us explore new data sets or find emerging patterns faster. Incorporating machine learning into our innovation program means we need to build these capabilities in terms of building staff knowledge and expertise, as well as building processes and technical capabilities. This work cannot be done without the right tools and environment, and IT teams play a key role in providing the software and technologies to enable productionization, as well as the exploration and development of these emerging approaches. This can be challenging with rapidly evolving methods and technologies available, as well as the computing power demands of some machine learning methods and applications. Machine learning needs a range of experts to work in partnership, including IT teams, statisticians, data scientists, and also expertise from subject matter areas who are crucial to help us understand and improve machine learning models. In summary, there are some challenges but also opportunities for machine learning to contribute to official statistics. And in return, NSOs can play a key role in informing developments in this field. Thank you for listening.
Great. Thanks, Jenny, for that very clear and comprehensive overview of possibilities of machine learning. And I see already that's generated some questions in the chat. So we'll go straight away now to our second presenter, and then we'll take the questions afterwards. So our second presenter is Alejandro Ruiz, who is a researcher at INEGI in Mexico. And he joined INEGI in 2016, and since then has carried out projects on economic productivity, measurement of household income, and data science for the public good. So Alejandro, the floor is yours.
Hey everyone, can you hear me?
Yes,
okay.
That's fine, thanks.
Excellent. Well, first I want to thank the organizer for this kind of invitation to share some of the experiences we have in using machine learning. So I want to present these 3 projects. Just one of them is already finished, which is the following. So please, the next slide. At INEGI, we began our journey to machine learning from this project on, in which we wanted to explore the range of possibilities social media offers in terms of new data from non-traditional sources. So we partnered a university whose campuses are all over the country. So we both took the task of labeling a significant database. Over around 54,000 tweets were multi-tagged by 10,000 people from different areas of Mexico. So we asked people tagging to assign a label based on the emotion the tweet transmitted to them. So we ended up with a ground truth database, which was used to apply natural language processing, NLP. So as a first step, we did some pre-processing. Then we use a method called TF-IDF to vectorize, and then we use super vector machine model to classify, to make the classification. This process led us to get an accuracy over 86%. So we get more than 90,000 geotag tweets on a daily basis, adding up more than 300 million tweets so far. So every new tweet is labeled automatically by the machine learning algorithm, either as a positive or negative one. So to report these results, we designed this beautiful and full of information web page, which you can link. You can see the link above. So in this page, we are able to track this positivity quotient, which is the total number of positive tweets divided by the total number of negative tweets. So some of the counts we can you can imagine. So this project, this positivity quotient only reflects the emotion of people tweeting and cannot be generalized to the entire population. So the public AP from Twitter has some restriction on the number of tweets and fields you can get. So some reweighting statistical methods are not possible, so or are very difficult. So the next slide, please. This is a brand new project, an ongoing project which seeks to exploit the advantage of getting geographical and sociodemographic data within the same institution. So recently, INEGI has put a lot of effort in developing capabilities and acquire inputs and tools needed for remote sensing. One of the many projects currently underway aims to identify vulnerable settlements in terms of deprivation of basic resources in a timelier manner. So as you know, censuses are conducted not very often and they are extremely costly. So we need a solution to get some information more timely. For that, we develop a continuous index based on several census sociodemographic variables at a block level. Next, we partition Landsat images in grids of 600 by 600 meters and match an index value to a specific grid. Next, we develop a deep learning algorithm for supervised learning. This is a project where you can clearly see the need for a multidisciplinary team. You have the geo expert, the machine learning expert, the satellite imagery expert, the conceptual expert, etc. For the same, there are multiple challenges. For example, measuring what is appropriate, measuring in the right way, getting features from the images or improving the accuracy metrics. So the next one, please. So this final project is about classifying coding, occupation, and economic activities variables. So there are common tasks to national statistics offices. So we work together to share experiences to solve the main challenges. One of those is coding variables asked in surveys, censuses, or captured in administrative records. Typically, the workflow is divided between people hired to assign a code to every record and some sort of computer assistance. The coding process made by humans can take significant time, especially in large projects like censuses. So also the quality of the coding may vary between people depending on their level of expertise. So we took this survey whose purpose is to get information on household income sources and expenditure patterns. So based on certain textual responses, a numeric code is assigned to both economic activity and occupation variables, either by a deterministic algorithm or by a human expert. This is what we currently do. So with machine learning, our goal is to improve the percentage of records coded automatically and help to improve the quality of the coding. So we develop a methodology based on natural language processing plus machine learning ensemble to code some records before they are assigned to a human coding expert. That way, we can reduce the workload for them and do the coding in significant less time. An important point is that the machine learning algorithm can code the entire data set. However, we just take those records for which the algorithm is more certain. So our estimates indicate that we can reduce the human workload by 40 to 50% with an accuracy near 90%. So some of the challenges we faced for this project are related to computational burden. So we had to process many features, sometimes with a big data set. So that's what I want to share with you. So thank you for listening.
Great. Thank you, Alejandro. That's great. And some very good examples there of how machine learning can work in practice, which I think has also generated some more questions in the chat. But before we come to the questions in the chat, we are going to just ask 5 questions, which, as I mentioned earlier, have been synthesized from the many questions that you submitted when you all registered for this webinar. So I'm going to give each of the presenters a minute or two to answer each question. So we start with the first one. What is the starting point for the use of machine learning for official statistics or national statistical offices? How can machine learning be applied in developing countries, given the required technical capability and infrastructure requirements? So really how to get started. And Jenny, do you have any suggestions on that?
So I don't have any suggestions about how to apply in developing countries. I don't have that experience. But in terms of a starting point, like the starting point is always to have an articulated strategic direction that's driven by the business need. For example, modernization or ensuring relevance of an NSO. And because, as I mentioned, this work can't be done in isolation. It needs to be done with a variety of skills. So you need other expertise. So access to these skills either within the organisation or through partnerships, such as with the universities. So for both of these things, you need senior management buy-in, for example, to facilitate the different teams working together and working towards the strategic direction. And Steve, I think one of the things you were suggesting earlier is that it can be a really good idea to join an existing international initiative. And it's a really great idea to form collaborations and learn together with others. And anyone from the statistical community is welcome to join HLG MOS collaborations. And although the machine learning project is wrapping up in coming months, there has been some discussion that we would like to see some form of ongoing community building on this engagement so far. And we're not sure what format that's going to take, but it'll be around exchanging and collaborating.
Great, thanks, Jenny. Yes, I think taking advantage of the knowledge and the ideas that are out there in the statistical community globally is very important. Alejandro, your views on this question?
Yes, for the starting point, I would say the necessity to provide solutions that traditional methods are not being able to bring. Currently, if a traditional statistical method has a solution or a possible solution to your need, the statistical office are more prone to use it instead of using machine learning. So you have to have a necessity in which the traditional statistical method has not a clear solution. So for the technical capabilities, okay, one option we find very useful is to partner with non-profit organization, with academia, with another NSO, which are in a better position. So ask for guidance and work closely in a specific project has helped us a lot. Also, some kind of infrastructure has been developed by international organizations to address the lack of IT resources in developing countries.
Great, thanks for that. I'll move to a possibly sort of related question, which is all about sharing resources for machine learning applications. So the question is there availability of public tools or algorithm repositories for implementation in official statistics for practitioners? So where to find these resources developed by others? Jenny, do you have any ideas on that one?
Yes, I guess just a reminder that the outputs from the machine learning project will be available in a few months, including some of the code that was developed. And also one of the work packages is about challenges and successes of integrating machine learning into an NSO. And that includes a section on capability and useful materials, so capability building and useful materials. So keep your eye out over coming months for that. But machine learning training materials, there's a lot available online now and ever growing. And environments such as Google Colab, for example, has a lot of associated materials and YouTube tutorials and the like that people can use, as well as increasing open source machine learning software and packages. But I guess I'd just say, if you're going to be using some of these, just be mindful that you won't be able to put your real data into some of those environments outside your own. And if you're going to be downloading anything into your work environment, you'll just need to check in with your IT area, because they'll want to have a look at security and computing infrastructure requirements and access to the internet and things like that. And also your procurement area, because they'll want to have a think about the licensing. And I guess just another note is, like, it's a really great idea to share methods and approaches and tools, but just be mindful that you'll need to make it relevant for your own context. So you'll need to make it relevant for your data, what you're trying to do, what your data users actually key needs are.
Great, thanks Jenny. Alejandro?
Yes, to the best of my knowledge, there are some statistical organizations sharing publicly the work they do, either as repositories in GitHub or in any kind of form of academic research. At INEGI, we have not started to openly share the algorithms or methodologies we develop in this project, but there is this idea to do it soon. Sorry.
Great, thanks. I see also in the chat a comment from Pedro Campos to say that at the level of Eurostat, there will be a repository of tools, methods, and algorithms to be shared by the community. And there are various repositories that are sort of relevant to this, things like Algorithmia, which is basically a web platform for sharing algorithms. And also I mentioned the UN Global Platform, which is a shared computing environment developed in the context of the Big Data project. But it's a resource where people can share algorithms, tools, etc., test out new ideas, new software on non-confidential data sets. So there's a growing number of resources like this that are starting to become available. And I see somebody has, yes, put a link to the marketplace in the chats. So thank you, Sioli, for that. That's part of the UN Global Platform. So third question, has the potential for building data quality, validation, data checking into data collection efforts using machine learning techniques been explored? So this is basically putting machine learning right into the start of the process, into the data collection phase. Jenny, anything in ABS on that?
So a couple of examples I can think of is around, one example is around editing. So we've done some exploration about whether machine learning approaches like PCA or association rules, random forest, can be used to actually find editing rules. And they've all got their pros and cons, but there does seem to be some common themes on the work we've done so far. Like these approaches can identify rules, but they tend to identify an awful lot of rules. And some of the rules that they identify are overlapping and some are conflicting. And some of them are quite hard to interpret. And you really need an expert to interpret some of these rules or identify what the best ones are, but also to help tell whether or not the rule itself is actually appropriate. So that it can take a bit of work at that stage, and the expert needs to sort of go along on a bit of a journey for machine learning and understand it themselves. So that can take a bit of time. And I guess the other thing is that when you're using machine learning to try and find potential anomalies in your data, they tend to find unusual data rather than necessarily wrong data. So again, particularly at that early stages, you really need expertise to help you figure out whether or not what you're identifying is actually wrong and needs editing. Actually, the HLG MOS editing and imputation theme, there's a group around editing and imputation. So they've got a report that will be coming out in a while, but they're also presenting to the upcoming UNEC Statistical Data Editing Workshop. And I believe also to the Big Serve 20 conference. And the other example I was thinking of was perhaps just going back to that dwelling occupancy example I talked about, where we're trying to impute family structure of non-responding dwellings. So we're trying to predict whether it's occupied and unoccupied, and also impute people into the occupied dwellings. And we're also trying to incorporate whether we have strong or weak level of information about that particular dwelling. And then we use that prediction for the imputation. And I guess just a final reminder is that there are things that machine learning can help us with, but just a reminder that machine learning can't fix everything that's wrong in the data. So thank you.
Great, thanks Jenny. Alejandro, anything from INECI on machine learning around collection?
Oh, just I want to say we are very aware of the potential, but so far INECI has not done some exercise or some research on this subject.
Okay. So next question is about transparency. So we've always historically in statistics, we've put a lot of importance on transparency of methods. But how can we maintain and ensure transparency with the application of complex machine learning models, which can often be something of a black box, so really hiding what's happening. How do we manage to balance that transparency with the complexity of machine learning? Jenny?
Yes, I touched on this a little in my presentation. So there are emerging methods and approaches and software packages and online training resources that are becoming available to help with this. And NSOs need to work out how to use these things in a way that's appropriate for our needs. So a couple of examples, like the Lime and Daleks R packages, for example, help you interpret what the machine learning is doing, providing some diagnostics, say, around variable importance and the like. But there's still gaps in this knowledge around the diagnostics and the quality metrics as well. And obviously that's an important part of these directions. That's the sort of thing that NSOs need to be working on. One of the, like just an example of one of the projects that ABS is doing at the moment for research is understanding whether replication methods that are used for traditional estimation can also help us understand how stable a prediction is, for example, if we're using a neural network. So, and can we even use a neural network to create standard errors? And can we even structure the feature layer to have some key characteristics, like can it be interpretable? Can we make sure the first features are the most important? And can we actually have independent sampling error through that process? So there is a lot of work to be done to better understand this aspect of the work, but also more broadly around the concept of uncertainty in the context of machine learning. And again, the HLG-MOS machine learning group is working in this space with their quality team has been looking at various metrics, and they're developing a quality framework for statistical algorithms for official statistics. And some of the dimensions are around interpretability, accuracy, reproducibility, timeliness, and cost effectiveness. And there's been some discussions about related concepts, such as reliability. So that's part of the work that'll be released as part of this group's output. But I guess just a final comment is one of the challenges is we want to be able to understand what's happening and how the machine learning mechanism is coming to a particular decision. And we want useful metrics around that and quality outputs. But one of the challenges is sort of providing accurate and robust outputs with these metrics, but doing it in a way that's computationally efficient as well. Thanks, Stephen.
Great. Thanks, Jenny. Alejandro, your views on transparency with the black box of machine learning?
Yes, just to add what Jenny said, this idea that we should pursue the balance between parsimonious models and precision metrics, because sometimes we tend to develop more complex models to gain some few percentage point in precision or accuracy metrics. But sometimes it's better to keep simple models, so that we can replicate or we can understand better what is being done in the model.
Absolutely.
Great, thanks. Now we're just about out of time for this segment, but one last very quick question. How do you persuade old school traditional statisticians to use machine learning? how do you persuade them that it's something worth looking at? Jenny?
I guess just to comment that they have a lot to offer. I have an analytical background, but I work with statisticians and methodologists, and they really bring a lot of statistical rigor and understanding to the work that we do. I guess if they've been around for a while, they would actually have a good sense of how much work it takes to test and build an innovation into a production system. And they also know that it can be quite a journey, that they'll need to take some of the decision makers and the data users and all of the stakeholders within the organisation on a bit of a journey. And we were talking before about, demonstrating the value add of machine learning. So I guess, and in some ways, some of the techniques that they've been using for quite a while will actually be quite useful for making machine learning appropriate for the needs of an NSO. There are some, if it's around, because sometimes it is around the fear of the unknown, and I think we've all sort of been on that journey. So there can be some really useful gentle introductions to machine learning, and one of the things that Suming Tam pointed us to is a YouTube mathematical monk session, so you can look that up. That's really quite useful as a gentle introduction. And then, just recapping on the value add. So the machine learning projects, the work package 3 that I mentioned before, will actually be looking into the sorts of problems that are suited to machine learning and how to demonstrate the value add of machine learning to your decision makers. So thank you.
Great. Thanks, Jenny. And Alejandro, how do you persuade colleagues that machine learning is worth looking at?
That's a hard one. I do not see machine learning as a panacea that can be applied in any project. Usually, machine learning is being used to address some specific challenges that traditional statistics have not been able to solve yet, or are not suitable for the type of new data being produced. So by delivering good results on specific projects, you can convince almost everyone that machine learning is worth to explore. So also it's important to show quality and accuracy metrics people are familiar with, and metrics that are easily understood by almost everyone. I believe those points are important to persuade almost everyone to use machine learning.
Great, thank you. In my experience as well, I think one of the things that helps convince particularly senior managers can be that if you look at the statistical production process, and you can do that, for example, using the GSBPM, Generic Statistical Business Process Model, you can try to see where the cost centers are. Where does the statistical production process cost the most? And it's almost always in data collection, data editing, maybe classification, etc. And so by showing the possibilities of techniques like machine learning to vastly reduce the costs in some of those areas and allow resources to be reallocated into areas that can boost quality even further or improve timeliness, whatever, is often quite a good business case for areas like machine learning. So we come to the end of the 5 questions from the registration forms, and now I think we have about 20 minutes left. We're going to take a look at some of the questions that have been coming in on chat. I'll start by apologizing because I've seen many questions going through on the chat screen, and we won't be able to get to all of them. But my colleagues in New York have been drawing out maybe a few of the common themes and some of the ideas from the questions. And they've sent me at least a starting point of 3. So we'll go through those and then we'll see if there's time for any more to come along later. So the first of these questions from the chat is related a little bit to the transparency issue we talked about a few minutes ago. And that's, how do we assure the fundamental principles of official statistics with the use of machine learning? So how do we make sure that our statistics are in line with the fundamental principles in terms of things like methodological soundness, independence, transparency, as we discussed, etc. So Jenny, do you have any views on that?
I feel like I might end up repeating myself a little. Yeah, it's one of the, I guess one of the challenges in this space is that so far we're still working on the metrics, because we have an existing system and process with traditional methods, and we know how to measure soundness and understand transparency. And I think one of the challenges with some of these emerging solutions is, how do we come up with these metrics and design our clearance processes? Because we need to understand ourselves, and we need to be able to show our data users that we have applied robust methods, and that there are quality metrics, and that those things are actually understandable. And at the moment, in some cases, they're still being developed. So we're sort of all going on a bit of a journey here. But the good news is that some of the more familiar approaches might be useful in this space.
Great. Thanks, Jenny. Alejandro, there was a question from the chat specifically to you. So there's a lot of interest in the vulnerable settlement project in the questions in the chat window. Could you just say a little bit more about that, and particularly if there's a link where people can get some more information? Thank you.
Unfortunately, this is an ongoing project. We just started this project, so there is no link yet, but we hope soon to get some results to show you. But yeah, we don't have any publicly links yet. Just want to tell you that our goal is to identify in a more timelier manner some sort of vulnerable household or areas, especially in areas, in poor areas, in which surveys or people are not getting any information, like surveys or admin records or kind of. So no, but as soon as we can get some results, we can share with the community.
Oh, great. I'm sure we all look forward to seeing some papers coming out at relevant conferences over the next few years on that and various other applications we've heard about today. Which sort of links me to the third question from the chat, which was one actually more directed towards me, and that is whether there's a working group for people to exchange experiences and manage alliances for development and application of machine learning in official statistics. Well, I think the simple answer at the moment is that there is currently no single working group for that, but there is quite a lot sort of in development. So we already heard today, for example, about the group on statistical data editing. They've been talking about machine learning on and off for the last few years, with a particular reference to machine learning for data editing applications. We also have the Global Working Group on Big Data, which I know has been looking at various machine learning techniques, for example, in the context of using satellite image data for agriculture statistics. And of course, as mentioned by both presenters, there is the ongoing machine learning project. And as Jenny mentioned, that project is actively looking at how to create some sort of community for machine learning in official statistics going forward. So I think you'll find machine learning in different areas, and there will be a group going forward. I think we can see from the fact that there's over 300 people who joined this call that there's a strong interest to have that sort of community as we move forward. Great. So another question coming in from the chat is around cost. And this is often a key part of a business case. And I wonder, Jenny and Alejandro, do you have any examples of how machine learning can reduce actual cost of producing statistics, or at least some estimates from areas that you've been working on so far? Jenny?
I'm afraid I don't have actual numbers on that to share, Stephen, but we go through a process where, you know, the normal R&D process where you look at a potential idea and you assess its feasibility, and then there's a decision point where it goes to the next stage and you might develop a prototype and you start to test it against case studies. And it's a really good idea to start bringing in particular areas who are interested at that stage so they can really inform the prototyping process and also start to go on the journey themselves in terms of how much it's actually going to save them, say in manual effort or something like that. So yes, unfortunately I don't have any actual figures that I can share.
Great, thanks Jenny. Alejandro, anything from INEGI in savings?
Well, it's difficult to bring some cost because you have to think in the future. So, but for example, to give you just an example, for this coding process we are developing at INEGI, using machine learning can help you to reduce almost 50%. So half of the people you are using currently for coding, we are currently using for coding. Machine learning can take those tasks made by this coding expert, human experts. So in censuses, it's a significant amount of humans you must hire to do the coding process. So you can imagine just coding half those costs by using machine learning do the coding or part of the coding.
Great. Yeah. So I remember an example from a presentation by my colleague In Kyung about machine learning on the subject of coding. And there, if I remember right, it was something like 16 times quicker, something like that. In Kyung can correct me in the chat, but there was a significant time saving over the previous manual process in various studies. And I see that Claude Julien, who is leading the machine learning project, has put an example in the chat from the Bureau of Labor Statistics in the United States. And they showed improved accuracy, which is an interesting side of things. So a machine can actually be more accurate for coding. And certainly in my experience, a machine is at least more consistent. It will tend to be more consistent than humans would be. So Claude gives a link there as well to a YouTube video that gives more information on that.
Yeah, that's a very good point. The consistency side of things, because it takes a lot of humans to do the coding, and a lot of effort goes into making sure that they are making decisions in a consistent way. But obviously, having a machine that does it, and then you will actually increase the consistency. And indeed, it's evidently faster. The address register example, they've just made massive improvements because of the speed that it goes through and the volume that it's able to go through. And the quality is also improved because it means that your coders are able to focus on the more difficult examples. So the machine can churn through a lot more of the simpler coding tasks, and it frees up your experts to actually focus on the more difficult things, which it turns out from what people say, it's more interesting for them as well to look at the more difficult problems.
Great, thanks, Jenny. So we have just a few minutes left. We certainly won't get through all the questions, but one question that's been mentioned was about how can machine learning techniques be used for imputation for missing data? So I don't know, do you have any examples or any experience of using machine learning for imputation? Jenny?
There we go, I'm unmuted. At the moment, the work I've been doing has been mainly around looking at editing and identifying potential anomalies. But I was actually just in a session earlier today that was run by the Stat Society Australia, and they were actually going through an example where they'd applied Python to assess 12 different supervised machine learning algorithms to try to resolve a missingness and try to impute some values. So they've actually been developing a bit of a Python package to do that. So I think they're going to actually be releasing that paper as well. So just keep an eye out for that. That sounds quite interesting. But myself, I have not, apart from the example we talked about just before, where we're trying to impute people into actual households and prediction that way.
Great. Yeah, thanks for those examples. Alejandro in INEFI, machine learning for imputation.
No, we are doing some imputation methods, but not with machine learning. So I believe the important thing in imputation is not the method, as important is the variables you are using to do the imputation. So for most surveys, there is this problem that the records are not missing at random. So, so you have to come with a solution with some sort of variables that that you can use to that can be useful to replace this problem that missing at random more than the I believe more than the imputation process doing by machine learning or by any other statistical method.
Great. Thanks.
Sorry, Stephen, it's Jenny here. I'm just seeing the chats come up, and of course I've forgotten to mention the HLG machine learning group about editing and imputation. So obviously they've been doing some project work in this space, so they'll be publishing those results soon.
Great, thanks. So I think now it's coming to the last few minutes of the webinar, so I should probably start to sum up. I think from what we've heard, this is a very interesting area of official statistics because it's an area that's new, it's experimental. We don't necessarily have people who are lifelong experts in this topic because it hasn't been around that long. This is an area where pretty well all statistical organizations are just really starting out. And so that means it's a really good area for international collaboration, because if we're all starting out at about the same time, the worst thing we could do is sit in our own corners and all make the same mistakes. And that's why I think it's vitally important to have activities like this where we just talk, where we share ideas and experiences around the community. And I think that's something we will definitely need to keep going with machine learning in the future, so that we can all learn from the ideas, the experiences of each other as much as possible. And hopefully, along the way, share some algorithms, some tools as well, so that, again, we reduce the development cost for everybody. I was asked to point out as well that this webinar is part of the series leading up to the World Data Forum. That forum in its physical sense has been moved until 2021, so 3rd to 6th of October 2021, for obvious reasons with the COVID-19 crisis. But to keep things going, there will be a virtual forum, which will be 19th to 21st of October this year. And there'll be information about that all over the internet, all over social media. And I see my colleagues in New York put also the link in the chat box as well. So please go to that and you'll get information about other webinars in this series, about what's happening with the World Data Forum itself and the virtual forum, which will take place in October this year. What I would like to suggest to everybody on the call, and this is something that was recently told to me as an idea of capturing useful information, while you're still on the call, take a copy of everything in the chat box, because there are loads of really useful links and ideas and so on there. So I would advise you to just go and highlight everything in the chat box, do Control-C to copy it and paste it into Word documents or something like that, and keep it because of all the useful information that's been posted there by all the participants. So I think the only thing left now to do is to thank everybody involved. Thank you to all the participants, over 300 at one point, I think around 320 I saw the maximum. So that's really great. Thanks for all the excellent questions and comments. I'm sorry that we couldn't get round to all of them. Of course, it's impossible in the time scale. Also, particularly thank you to our two speakers, to Jenny and to Alejandro. And I'd like to point out that it's now, I think, past midnight for Jenny. and we started rather early in the morning for Alejandro. So thank you for putting yourselves out to join us today and to share your ideas and experiences. Now, I know we said right at the beginning that everybody should keep their microphones muted, but let's just finish with an experiment, which could be a horrible noise, but let's all unmute ourselves and give a round of applause.
This is going to be bad, huh?
Thank you.
Thank you, Steve.
Thank you a lot.
Thank you.
Thank you very much.
Bye-bye.
Guys, it was great.
Thank you.
Thank you. It was great.
Thank you.
Thank you.
Ginseng.
Amen. Thank you.
Thank you.
Thank you.
Thank you.